My name's Jasper Kirkby. I'm a particle physicist. A collaboration which I lead built this cloud chamber and built an experiment called Cloud. And we're doing this in the laboratory at CERN because here we can do everything under completely controlled conditions. Cloud has two very important goals. One is we want to figure out how cloudy was the pre-industrial atmosphere. And to do that, we need to measure the fundamental processes that are responsible for the formation of aerosol in the atmosphere and the clouds that they eventually seed. The only way to figure out the cloudiness is to make these lab experiments and then to run computer models based on sound physics and chemistry measurements. So here we are underneath the cloud chamber. That's the chamber itself. It's a 3-meter stainless steel chamber. And what you can see here is the lower manhole cover. And underneath the manhole cover are a set of valves. This is where we bring in all the different gases, the air, humidified air, ozone, various trace gases. Because what we do inside the chamber is we recreate a parcel of the atmosphere. This is actually the thermal housing that surrounds the cloud chamber. The chamber itself is inside. When we're ready, we start the experiment typically by turning on ultraviolet lights, which are actually injected through a fiber optic system in the top of the chamber. And that simulates the sunlight. It launches some chemical reactions, and then we basically cook the contents of the chamber over the next few hours and see what these vapors produce. Normally we have instruments attached to these. Everyone has an instrument, a very sensitive state-of-the-art mass spectrometer and other instruments, which continuously samples the contents of the chamber. And our second goal is to understand what could be the mechanism for so-called solar climate variability, which affects the cosmic rays on Earth and seems to impact the climate, certainly in the pre-industrial times. And this is where the CERN beam comes in, because the CERN beam is a beautiful artificial source of cosmic rays, and we vary the intensity of the CERN beam to see how processes change inside the cloud chamber behind me. What you see here is 4 large pipes emerging from the top of the cloud chamber, and each one has a valve. This is a big regulation valve. And what we do is we use these valves to actually form clouds, liquid or ice clouds inside the cloud chamber. And we do that by, first of all, raising the pressure a few hundred millibars inside the chamber, making the air very humid, and then we drop the pressure in a very controlled way using these valves, and that simulates a rising air parcel in the atmosphere, which forms a cloud. And in this way we can maintain a cloud inside the cloud chamber for 10 minutes or so. And during that time we change the particle beam going through the cloud from the CERN accelerator and look at direct effects of the CERN particle beam on the clouds themselves. I'm totally confident we'll be able to answer the question after a few more years exactly whether or not cosmic rays do affect the climate in a significant way.